Hey, so now we know what a logarithm is. Let's graph one. So one of the big things to remember about logarithms is that they are the inverse to exponentials. And remember, inverse functions mean we switch x and y. Also, remember that the graphs are reflected over the line y equals x. That's true of any two inverse functions. And when we're actually going and graphing logs, it's best to rewrite it as an exponential because it's way easier to plug stuff in. Okay, so what we want to do is we want to graph f of x equals log base 2 of x. So real quick, I'm going to write that as log base 2 of x equals y. So if we go through and kind of do our little log loop here to write this in exponential form, we have 2 to the y power equals x. So now normally we plug in for x and solve for y, right? Well, it's a whole lot easier to plug in for y and solve for x. It's still going to give us points on our graph. It's just easier to find them. So for y, or f of x, we're going to plug in -3, -2, -1, 0, 1, 2, and 3. Okay, so 2 to the -3rd, we've done these a million times. So 2 to the -3rd, I'm going to move my face for a minute so that way you can, there we go. Aren't it beautiful? All right. So 2 to the -3rd is an eighth. 2 to the -2nd is a fourth. 2 to the -1st is a half. Anything to the 0 power is 1. 2 to the 1st is 2. 2 squared is 4. 2 cubed is 8. So now I need to graph these points. Now, we just did x and y in reverse, right? Now, when you plot them, make sure you don't reverse it, okay? Otherwise, you're going to end up with 2 to the x again, and that's not helpful. So we want to graph 1/8 -3. So 1/8 -3. 1/4 -2. 1/2 -1. So over half up, down 1. 1, 0, so right here. 2, 1. 4, 2. 3, 4, up 2. And then 8, 3. So 5, 6, 7, 8. And then up 3. So graphing logarithms isn't necessarily difficult. You just need to make sure that you are paying good attention to what's going on. Now, as you might remember, when we graphed 2 to the x, it looked something like that, right? We have that line, y equals x, going between them. You can see that we reflected that exponential over to be able to get my logarithmic function. So I just wanted to point that out real quick. Hopefully I can go back and just get rid of all of my marks. Haha, it worked. I'm still learning, guys. All right, here we go. Now we want to analyze this. Okay, so let me remind you, inverses mean we switch x and y, right? Okay. So if we switch x and y, that would mean, remember, our domain are our x's, right? And our range is our y's. So if we switch our x and our y's, we're also going to switch our domain and our range from our exponential. So if we look at our domain here, we start over here at 0, right? And then we keep on going in this direction. So my domain is not -infinity to positive infinity. It's 0 to infinity. All right, remember, that was our range for exponential functions, right? Okay, well now let's look at our range for this guy. So our range is our y values. We have that arrow that's going to keep on going down. And then although it looks like the top part of this log is going to flatten out, it's increasing ever so slightly forever and ever and ever and ever. So for my range, I'm going from -infinity to positive infinity. And oh my goodness, that was our domain for our exponential functions, right? So our domain and our range switch. Now what you might remember from exponentials is that our asymptote was y equals 0, a horizontal line, right? Well, now we have a vertical line for our asymptote. So now it's x equals 0. So once again, x and y switch places. Our intercepts for exponentials was 0, 1. Here our intercept is 1, 0. We switched our x and our y. Have I beaten to your head yet that you're switching x and y? Have I gotten that through to you yet? No? You're switching x and y. Okay, so now let's talk about increasing, decreasing, constant, whatever. So if we had a little man walking on our graph, he would be walking up and up and up. So we are increasing over the entire domain. Now, since we're increasing over the entire domain, be careful. You need to actually put in what the domain is. Our domain is from 0 to infinity. Don't put negative infinity to positive infinity. Okay, so let's have a look at some end behavior. The end behavior here is a little bit weird. Put that in a different color, end behavior. Let's first talk about the left side. That's the weird side. The limit as x approaches. All right, so first of all, on our left side, we usually talked about where x approached negative infinity in this direction, right? Well, x doesn't approach negative infinity over here. So what do? Well, let's look on the left side of our graph. What is x approaching over here? X is approaching 0, right? So I'm going to have the limit as x approaches 0 of f of x. And then my function there is going down, 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 getting more and more and more and more negative. So that's going to be equal to negative infinity. On the right side, excuse me, popcorn. Stuck in my throat. All right. The limit as x approaches. So x does approach positive infinity on that side of f of x equals. And like I said, I'm going to keep on going up and up and up. Even if it's slightly, I'm going to keep on going up and up and up. So I'm going to be approaching infinity on that side. Here's what I would love for you to do. Please graph log of 1/2 x, log base 1/2 x, and analyze, and do me a favor, find that end behavior too. So hopefully your graph looks like mine. Domain is from 0 to infinity, range is from negative infinity to positive infinity, asymptote is at x equals 0, intercept is at 1, 0, and this guy is decreasing from 0 to infinity. I would do end behavior, but for some reason my computer keeps messing up every time I try to start writing an end behavior, and then my video gets all messed up. So we'll talk about it later. Sound good? Okay. I love you.